Hello guys and welcome to today's lesson. We are going to tackle two key questions. First, we will talk about the relation of temperature to net energy transfer and how heat energy travels in a solid. Secondly, you will go back to the 18th century whereby caloric and kinetic theories existed and their differences. The image atop is showing the relation of temperature to net energy transfer, and the question is, what is net energy transfer? So net energy transfer are flows that travel from a region of high temperature to a region of low temperature. This continues until both regions reach thermal equilibrium that can be seen right in the center of the line, where their temperature are equal and net energy transfer stops. The temperature is used as a measure of the average kinetic energy of a substance particle. A temperature gradient acts as the driving force for this transfer. The larger the gradient, the faster the rate of heat flow. This is showcased in the simulation above. The particle at 40 degrees Celsius moves much quicker, and where the particle at 5 degrees Celsius is much slower. How heat energy travels in a solid. It travels through conduction, and how it works in solid by elastic vibration. In all solid, particles such as atoms or ions are packed closely in a regular arrangement. When one end of a solid is heated, particles at the end gain kinetic energy and vibrate more vigorously. These hot particles collide with their neighbor, passing some of their vibrational energy along. This creates a chain reaction of collision that spreads thermal energy throughout the material, and this is how it travels through a solid. In the 18th century, the caloric theory, and here is an image of the caloric theory. It dominated science by viewing heat as a weightless, invisible fluid called caloric that physically flowed from hot objects to cold ones, filling the space between their atoms. In contrast, the emerging kinetic theory, and here is an image of the kinetic theory, proposed that heat was not a substance at all, but rather the result of internal motion and vibration of particles within material. This is proven in a Rutherford experiment named Count Rutherford Cannon boring experiment in 1798. Above is a clear image of the experiment taking place. While overseeing the drilling of brass cannons, Rutherford noticed that friction generated so much heat he could actually boil a large vat of water using only a drilling process. He argued that if heat was an infinite fluid stored inside the metal, it should eventually run out. However, the heat produced by friction appeared to be inexhaustible, as long as the horse kept turning the drill, proving that heat was generated by motion rather than released from a supply. In conclusion, heat always transfers from hotter to cooler regions until thermal equilibrium is reached. In solid, this happens through conduction, through lattice vibration. The shift from caloric theory to kinetic theory showed us that heat isn't a fluid but energy caused by particle motion.